Good evening, ladies and gentlemen. Welcome back to Edureka's YouTube channel. My name is Vardhan, and today we'll discuss the most commonly used Docker commands and how they work. So the commands that you see on your screen here, they are the ones which are most commonly used. So if you are a DevOps engineer or if you're just someone that's working on Docker, then you might have already used these commands or you might use them in the near future. Some of those commands are Docker version, Docker help, Docker pull, Docker run, Docker build, Docker login, Docker push, Docker PS. Here PS stands for Docker processes, and this command is used to see what are the active containers currently. And then you have Docker images, then you have Docker stop, Docker kill. There is Docker RM, which of course stands for Docker remove, Docker RMI, which stands for remove images. We have Docker exec, and this is used to access the bash of any active container. And then we have Docker commit, we have Docker import, Docker export, Docker container, Docker compose, Docker swarm, and Docker service. So these are the 20 plus Docker commands which are most commonly used. Now, without wasting much time, let me get started and discuss each of these commands. Docker version. This command is used to find out what is the version of your Docker engine. Okay, so remember, there will be two flags that will come in before writing version. And then we have another command which is Docker, again, two flags, and then help. Now, this is basically used to list down all the possible commands that you can use with Docker. So here, Docker will be a parent command, and whatever child commands that are possible here as permutation and combinations, those will be listed down. Now, let me quickly open my terminal and execute these two commands for you. Do remember that I will be using my Linux virtual machine, okay? And this Linux virtual machine of mine is an Ubuntu machine, and it's hosted on my VM, like I said. So I'm just going to open my terminal over here, and the first command that we were supposed to execute is Docker version, right? So as you can see, the version of my Docker engine is 17.05. Okay, so that's how this command works. Now the next command that we were supposed to execute is Docker help. That of course would also come with two hyphens. And like I told you, there are various commands that you have in Docker, like Docker attach, Docker build, Docker commit, Docker cp, Docker create, Docker diff. So all of these are the other child commands that can be used with Docker, okay, as a primary command. So I hope that was clear. And at any point of time, if you people have any doubt with respect to usage of any command in Docker, then you can just use the help, right? And help will basically tell you the different commands that are there along with a description. So it will also explain what each and every command does. Now, let's say you have Docker build, then you can see the explanation that it says build an image from a Docker file, right? So that's a good enough explanation. If I was a guy that's working on Docker, then I would know which option to use, right? Similarly for everything. So for Docker RM, it says remove one or more containers, and then for Docker start, it says start one or more stopped containers, and many more. So whenever in your free time, you can use the Docker help command and see what are the different commands possible along with their explanation. Okay, so I am going to clear the screen and go back to my PPT and check what are the next set of commands that I can execute. And remember, these are all still basic Docker commands. Okay, so the next command is Docker pull. Now the Docker pull command is used to pull any image from the Docker hub. Okay, and then we have Docker images command, which of course lists down all the images in your local repository. Now in the previous command, we do a Docker pull, right? So for the first time, you will not have any image in your local repository. You will have to pull it from your Docker hub. And when you pull it from your Docker hub, it gets stored in your local repository. And once it is there in your local repository, you can run the Docker images command and then check all the different images. So all the images will be listed down. Okay, so that's about these two commands. And then we have Docker run command. Now, the Docker run command is basically used to execute that image. And I'm pretty sure you are aware that whatever you download from the Docker hub are images, right? And if you want a running instance or if you want it to be active, then you have to run it, because what you will have to deal with, they are containers, right? And to get containers running, then you have to basically run those images. That's the same thing that we are doing here. The command is Docker run along with the image name. So supposing I'm pulling an Ubuntu image from Docker, so I will be using this command, Docker pull Ubuntu. Okay, and if I want to execute this image and get a running container out of it, then I would have to basically go here and run the command docker run along with that particular image name, docker run Ubuntu. Okay, guys. So I think you have a decent understanding of these three commands. Now let me again go back to my terminal and execute these three commands and show you how they work. So I'm back to my terminal here. Okay, so here let me write down the command docker pull Ubuntu. Now by running this command, I am pulling the latest Ubuntu image from my Docker hub. Okay, so when you hit enter, in spite of the fact that I did not specify any tag over here as latest, it's pulling the latest image that is available on the Docker hub. Okay, so let the process happen, guys. Give it a minute. Perfect. So now you can see the status here, right? It says it has downloaded a newer image for Ubuntu, that is with the tag latest. Now if I want to check if this image has actually been pulled, then I can run the command docker images. Now let me run that command by first clearing the screen and then actually running the command docker images. When you hit enter, like I said, you have the entire list of images available in your repository over here. The entire list is down over here, correct? So you have custom image, you have /custom image, right? So this is another image which I created. If you want to check if your image is latest, then you look at Ubuntu here, right? So this has the tag as latest, and this was an image which was created 10 days ago in my local repository, and it is about 112 MB. Okay, this is the one which we downloaded recently, and it has the latest tag. So this is how you check the different images that you have in your local repository, guys. Okay, so I'm going to clear the screen, and now it's all about executing a Docker image. So for sample purpose, I can even run any kind of an image and get a container, right? So before I execute an Ubuntu image, let me execute a simple hello world container. So for that, I'm going to say docker run hello world. Now remember, when we say docker run hello world, you might ask me a question that, is hello world already present in my local repository? Well, the answer is it's actually already present. So I have an image of hello world in my local repository, but even if I do not have the hello world image in my local repository, this command will run, because when you do a docker run command, this would first of all look for this particular image in your local repository. If the image is not present, then it will go to the Docker hub and look for an image with this particular name, and it will pull that image with the latest tag. Okay, so run does two things: it pulls and it executes. Okay, so let me hit enter, and there you go. It says hello from Docker, right? So this is the hello world container for Docker. Now the reason I did not execute the Ubuntu image is because I want to make a few modifications to that image. But if you want to make a few modifications to that image, then you have a different set of commands which are involved. So let me go through those commands and then get back to what I was supposed to do. That was about docker run. And then we have something called as docker build. Okay, and this docker build command is used to build a custom image of yours. Supposing you have an Ubuntu image, okay, but you do not want it exactly as it is, and you want to make a few adjustments to that. So another example for that would be the node image, right? In my previous sessions, I've had sessions on Docker Swarm, I had a session on Docker Compose, and many more, right? So over there, what happens is I'm using a Node.js image as my base image, and then I'm building my entire application on that. So what you have here is you have a base node image, okay? And on that node image, you build your entire application, be it an Angular application or be it a mean stack application. And the command that you use to build the entire application is the docker build command. And as you can see, this is the syntax. You have to say docker build with the flag -t. And the T flag, what it does is it basically tells you that you can give your name with a tag for your image which you're building, because this image is going to be your image, right? You're customly building this image. So when you custom build this image, you can give it your own name, and that's what this is. And followed by that, with a space, I have specified a dot here. Now the dot specifies that the Docker file which is needed to build this Docker image is present in the current directory where this command is being executed. Now, had I specified the entire path of my Docker file, then I wouldn't be specifying the dot over here, right? But in that case, if I'm specifying the entire path, then that means that my Docker file is present in some other location, not necessarily in the same location where the command is being executed. Okay, I hope that was a little clear to you people. So now if you're still not clear, let me give you a demonstration and then you will be able to understand this in a better fashion. Okay, so let me open my terminal again, and currently we are in the /home/edureka directory. Now for the demo purpose, I had created a new Docker file. Let me first open and show you that Docker file, okay? And that Docker file is present in the downloads demo folder of mine. If I do an ls, there is a Docker file. Perfect. So let me say cat Docker file. In fact, let me open this in gedit. So sudo gedit Docker file. Yes. Now the Docker file is the most important file if you want to build your own custom images, because whatever you want for the application to run, those dependencies are specified in this file. You have to say which is the base image that you have to first of all download from the Docker Hub and use that as a basis for your application. And then you have to say the other commands that you want to run. Now in this demo of mine, I'm simply downloading an Ubuntu image from the Docker Hub and I'm just echoing this sentence. Hi, this is Vardhan from Edureka. So it's a very simple process, right? I'm pulling one Ubuntu image and I'm doing an echo on that particular image. So you can just save this, close this Docker file, and then execute this particular Docker file, okay? And since I am in this folder, I can use the dot to specify that the Docker file is present in this directory. Now let me first clear that screen and then run that command again. So the command is docker -t. Let's give the name of the image as my custom Ubuntu image. Custom Ubuntu. Well, that's good enough, right? And then I'm going to say dot because the Docker file to build this my custom Ubuntu image is present in the same path. Okay, so it says my custom Ubuntu should be in lowercase. Okay, no problem. So let me just check my Docker file once. Okay, now the reason I got this is because my image name cannot be in caps. So what I'm going to do is let me rerun the command with a different name, possibly in small letters. Okay, my custom Ubuntu. Okay, perfect. The command got executed. So if you can see here, it says sending the build context to the Docker daemon. And since I had specified only 2 steps in my Docker file, those 2 steps are being executed here. Step 1 is it's pulling the Ubuntu image from the Docker Hub. And since it's already there in my local repository, it's using whatever is there. Okay. And step 2 is running the echo statement. Hi, this is Vardhan from Edureka, right? This was the second step. And the same echo command has been executed over here. Hi, this is Vardhan from Edureka. Correct? Perfect. So I hope you guys got a good understanding of this particular command, because this is the most important command if you want to make it as a DevOps engineer or a person that's regularly working on Docker, because all of the images that you will be working on in your office or in your workspace, you will have to be working on custom images for your application. So remember how this command is used and how the applications are built. So let me just clear the screen and go back to my slides and see what is the next command in store for us. Okay, so the next command is the Docker container command. And this Docker container command is basically used to manage your containers. Now let's say you have n number of containers, and because so many containers are active at the same time, your system may be lagging, right? There's a performance issue. So at that time, you might want to close or end certain containers, right? Kill their process. So at that point of time, you can use the container command and kill the container straight away. So it's just one of the different options that we have. So there are a number of other commands which can be used with the Docker container as the parent command. And I would request you to look up the set of commands on Docker docs. Okay. But for now, let me just go back to my terminal and execute one of these commands and show you how they work. So let me go back to my terminal here. And here I'm going to run that command docker container, and let me run docker container logs. Okay, but so here let me run the command docker container logs to basically find out the different logs that are associated with my container. Okay, now the thing is, in arguments I have to specify the container name or the container ID, and since I don't know it right now, let me first find out what is my container ID. Okay, so I'm going to do a docker ps command to list down the different containers. Okay, there are no active containers, so I'm going to do a -a flag. So these 2 commands I will explain in detail at a later point of time, guys. Okay, but anyways, getting back to our problem here. you can see that the hello world container got executed, right? So I'm going to copy the container ID here, and now I'm going to find out what are the logs of this Docker container logs, and then I'm going to paste the container ID. This way, whatever logs were generated for this container, those would be displayed. Perfect. Worked as though the container executed again. So the same thing can be done for any of the other containers. Okay. If I do a docker ps-a and see there are so many other containers which are there right in my system, I can copy the container ID of any of these and I can execute the same thing again and again. Docker container logs, right? And then I can paste this. So this time the logs of this particular container, which is 916 and this entire ID, this logs have come out. And like I said, with Docker container, you have various other options, correct? You have options like Docker container kill, you have Docker container remove and all those things. So I can use a Docker container remove and hit enter. And basically when I do that, this particular container is off. So if you remember this ECC, right? This container is the hello world container. And when I said RM, this container is removed. So if I go back and do docker ps-a, then the first entry for the hello world container would not be present. And yes, as you can see, it's not present, right? The hello world container is not present here. Now that's what I want to show you. So I've cleared my screen. And now let me get back to my slides. So I basically executed the docker container logs command and the docker container rm command. So you have various other options. Like I said, you have the container kill, which can be used if you want to kill any one particular container. Okay, you can use the docker container run command to start any container which has been temporarily stopped or which is inactive. Okay, and if you want to again start the container from something that has been stopped, you can use the docker container start command. And these are just a few of the commands, and the entire list of docker container commands can be found in Docker docs. Okay, so I would request you to go to Docker docs and then see the entire list of commands if you want to learn more about this command. In the meanwhile, let me go to the next slide and continue with our session. The next command that we're going to talk about is the docker login command. Okay, and as simple as it sounds, this is used to log into your Docker Hub account. Can any of you guess why we would need to log in? Well, it's for the simple reason that you might want to push any of your image that you have created locally, right? So when you're working with a team who are all using Docker, then you can just pull the Docker image or create a new Docker image from scratch at your end and build a container. And if you want to share that container with other people in your team, then you can upload it to Docker Hub, right? So how do you upload it to Docker Hub? So if you want to upload it, you don't have any other workaround. So you do it through the terminal. And to do it through the terminal, you have to first do a Docker login. Once you've logged in using your Docker container credentials, then you can simply start pushing your Docker image to the Docker Hub. Okay, so that's why this command is really important. So let me go to my terminal and show you this command. The command is docker login. When I hit enter, it says login with your Docker ID to push all images from Docker Hub. If you don't have a Docker ID, it says head over to this website. So this is where you can create a new Docker ID. Okay, and the username, it says in brackets, it says Vardhan NS. That's my username because I'm already logged in. So I'm just going to hit enter without entering the username again. And the password I can enter is my password. So that, of course, I'm not going to reveal to you people. But once you enter the password and hit enter, then it says login succeeded, right? If your credentials are a match, then you are successfully logged in. And once you're logged in, you can start pushing your Docker images, which you worked on locally, to your Docker Hub. Okay, perfect, right? So let's clear the screen and get back to our slides. Now, like I said, the next command is basically to push your Docker image to your Docker Hub. Remember, the command should have your Docker ID / the image name. Okay, my Ubuntu image, this may be the name of the image that you might have created locally. Okay, but if you want to push it to the Docker Hub, you have to tag it with a name, and that name should be your Docker ID. Okay, so let me get to the terminal and show you how this command works. So let me first look for the image that I want to upload to my Docker Hub. Okay, so when I hit Docker images, the list of all the images come out. And if you remember, my custom Ubuntu is the name of the image which I created. Now let me try pushing this image to the Docker Hub. Okay, so I'm going to copy this and first clearing the screen. And here I need to tag this image with my Docker ID, right? Because right now it has the name my custom Ubuntu and I cannot upload it to Docker Hub with this name. Now, since I have to tag it with my name, there's a command called docker tag, and here you have to specify what is the which image that you want to tag. So the image is my custom Ubuntu, and here let me specify my Docker ID slash the image name. So I'm going to say Vardhan NS. Okay, now that's my Docker ID, and slash my custom Ubuntu image, right? So this is the name of my image. I can even change the name, but I've just retained my custom Ubuntu as the name of my image. So when I hit enter, this image would be getting uploaded to Docker Hub. And now this image has been renamed to Vardhan NS slash my custom Ubuntu. We can verify the same by running the command docker images. And as you can see here, there is one image with the name my custom Ubuntu, and then there is another image with Vardhan NS slash my custom Ubuntu. Correct? Now this is what I have to upload. So now I can use the docker push command. So I'm going to say docker push and then simply specify the image that you want to push. Docker push Vardhan NS slash my custom Ubuntu. Hit enter, and the image would be getting uploaded to Docker Hub. And once when you do it from your end, after this command is executed successfully, you can go to your Docker Hub and check that your image which you created locally has been uploaded to the Docker Hub and it can be shared and accessed by other people. Okay, perfect. So this shows that my image has been uploaded, and let me just clear the screen and get back my slides and move forward. And this command is something that I already executed some time back, right? If you remember, I used the docker ps command to identify which are the containers which are currently active in my system, right, in my Docker engine. So that's what this does. PS basically stands for processes, and when you hit docker processes, then all the container processes which are currently running in your Docker engine would be listed. However, if you append this command with a 𝐴 flag, right, then all the containers which are inactive, even those containers would be listed down. So that is the difference between these two commands, docker ps and docker ps with a flag A. Now let me go to my terminal and show you that. So docker ps first, okay, and right now there are no entries because there are no containers which are currently active. But if you want to find out all the containers irrespective of whether they are active or whether they are not active, then it would list down all the containers in my system, right, or in my host, and that's what it's going to do. Docker ps -a, and as you can see, there's an entire list of Docker containers over here. There's the custom image which I created, and then there are various other images over here which I used to build a container, and I've shown you how they work in my previous sessions. So the contact list, Angular, and then there is a demo app one. These were images which I used for my Docker Swarm and for my Docker Compose videos respectively. So if you want to go and see those videos, then the link will be there in the description below, guys. And I would request you to go through those images to understand other Docker concepts better, okay? Because Docker Compose and Docker Swarm, they are the advanced concepts in Docker, and that's a must know if you want to make it as a Docker professional. The link for those videos are in the description below. So let me just clear the screen and get back to what I was doing. So the next command that we have is the docker stop command. Now the docker stop command is basically used to shut down any container. So if there is any container in your Docker engine which is running, right, in your host, and if you want to stop it, then you can use this command. And do note that this command would not be shut down right away. It might take a few seconds because it would be gracefully shut down, waiting for the other dependencies to shut first. Okay, it's not a forced stop. It's a very gentle stop. That's what this command is. But we have something called as a docker kill command. Okay, and what this docker kill command does is it ungracefully stops your container. As in, if there is any container that is actively running, it would straight away kill it. In spite of it's something similar to force kill, right? So that is the difference between these two commands, docker stop and docker kill. Kill would straight away kill your command. Now before I show a hands-on of this, let me go forward and talk about a few more commands. There is something called as a docker remove, right? Docker rm. This one, what it does is it removes a container. At this point of time, you have to remember that if you want to remove any container from your host, you have to first stop it. And how will you stop it? By the two commands that I explained in the previous two slides. You either force kill it or you kill it gracefully using the docker stop command or the docker kill command. And once you've used those two commands, you can remove them from your repository. Okay. And we have another command, that is the docker rmi. Okay. So the docker rm would remove containers. But if you want to remove images itself from your repository, then you can use the docker rmi command. Okay, guys. So these are the four different commands that we have here, which are regularly used. Now let me open my terminal and show you how they work. First, let me do a docker ps. And since there are no containers which are currently active, what I'm going to do is I'm going to start a service. Okay, I'm going to containerize a particular service, and then I will show you how to stop it or kill it or remove it. Okay, there is one particular image demo app one, okay, which I used to deliver my previous session. There was the Docker Compose session, right? Over there I used that particular image and I created an Angular application. So I'm going to first start that service, and the command for that is docker run -rm. I'm going to say port number is 4200:4200 because it's an Angular application. Let's give it a name. It's -- name, right? So let's give it a name, my Angular application, or let's give it a name, my demo application. Okay, and demo app one is the name of that image. So when you hit enter, first the image would come up, right? The image would be spun and the container would come up. Let's just wait for the container to become active. So let me first open a new tab of this terminal. Okay, and here let me run the command docker ps. And you can see that 42 seconds ago, this app was created, right? The demo app one. Here it says the webpack is compiled successfully. So if I go to my Firefox, the servers would be active. The Angular application would be active. Okay. But if I want to temporarily stop this container, or if I want to kill this, then I can use those commands docker stop, or I can use docker kill. Okay. So let's use those commands and see how they work. I'm going to say docker stop followed by the container ID, correct? Hit enter. So the docker servers are stopped. Now if I do a docker ps command, this container would not be active. Okay, and over here also you can see that which was temporarily compiled, it has ended, right? Even the service is not hosted anymore. So that's how the docker stop command works. So let me go to this command and restart the same service. And over here, this time instead of using the docker stop command, let me say docker kill. Okay, sorry, I've just used the same container ID, right? So I need to do a docker ps first. Okay, and yeah, now this is the container ID which I have to kill. So I'm going to say docker kill, pasting this container ID and hit enter. And that container has also ended. So even the service has exited from here, right? So that's how you kill a container. That's the difference between the stop command and the kill command. Okay, so I'm just going to clear the screen. And after these two commands, there are two commands like docker rm and docker rmi, right? They are used to remove containers and images respectively. So let me go ahead and do that. First, let's run the command docker rm. Okay, and now you have to specify which container you want to kill or remove. So for that purpose, let me first find out which are the different docker containers that are there in my system. So when I do a docker ps -a, there are a number of containers, and from here let me remove this test Angular container. Okay, this is the name of the image and this is the container ID. So I'm going to copy this container ID and go back here. Let me clear it, and here let me run the docker rm with the container ID. And when this is returned, it means that my container has been deleted successfully. And the benefit with this is I have freed up a little more space in my host, right, in my Docker engine. Now guys, similarly, we saw how to remove a container. Okay, now let me go here. Let me do a docker images. So these are the list of the different images that are there in my repository. And if I want to remove any of these images, then I can do docker rmi. And what we have here is we have a Redis image and we have an Alpine image, which I do not need. So let me copy this Redis image and remove this image from my repository. So the command is docker rmi this time, because remove image is what it stands for. And I can specify the image name, or I can even specify the image ID. So image name is good enough. So That's what's happening, right? It says untagged and deleted. Perfect. Now I can clear the screen, and what I wanted to show you, I've showed you already. Now if I run the docker images command again, then Redis would not be visible here. So you can see Alpine, but you can't see Redis. Correct? So that's how it works. So let me go back to my slides and go to the next command. We spoke about stop, we spoke about kill, we spoke about docker rm, and we also spoke about docker rmi. Now the next command that is in question is the docker exec command. Okay, and this command is used to access any active container, right? Any container that is actively running. If you want to access the bash of that particular container, then you can use this exec command. Okay, and we use IT flag over here. So you can either use -IT together, or you can use -I space -T. Now what I does is it's basically, it says access your container in interactive mode. So that's the option this flag specifies, and that's why we're able to access the container. Okay, and you have to specify which container you want to access, followed by the word bash. So let me go back to my terminal and show you how that works. So over here, let me clear the screen and do a docker ps and check which containers are actively running. None of them are running right now. So let me start a container over here. Okay, let me do a docker. In fact, I can start one of the containers I started sometime back. The demo app one, right? The one I spoke about is the Angular application. Let me start this same container. Let's wait for it to come up. Perfect. Now it says Webpack compiled successfully. So now let me go to my browser and hit localhost 4200, because my Angular application is active on port number 4200. Right. So this is that Angular application which I was talking about. So if I go back to my terminal, you can also see that I have specified 4200 as the port which is to be used to access that application on my host. And this is the port number it's running on internally in my container. So I'm mapping my container port to my host port. And because of this, I could access that Angular application on my web browser. Now, getting back to our slides, we were supposed to use the docker exec command to access this container, right? So right now, I cannot access this container over here. So let me access this container in a new terminal. So this is the new terminal. And here, if I do the same docker ps command, the new container is active. So from here, let me copy the container ID and then run the command docker exec with the flag IT, followed by the container ID and then bash. Bingo. So right now I am inside this container. So all this time, this was the user, right? Edureka @ubuntu. This was my host machine and this was my username. Right now, I'm logged in as a root user inside the container with the having the ID this one, because this is what I specified over here. So now we are not in my local system, we are inside the container. And what can we find inside the container? We would basically find dependencies, libraries, and the actual application code of this particular Angular application which is hosted over here, right? Which you can see. All the project codes would be present inside this container, correct? So let's verify if that is the case by checking if we are actually there. And by doing an ls, you can see all the different files here. We have a Docker file which was used to build this application, and then we have a package.json file, which is the most important file to build any Angular application or any main stack application. And then we have protractor.conf.js, which is used to test any Angular applications. And then we have so many others, right? We have an src folder, we have an e2e folder, and then we have node_module. So this is where all your project dependencies are stored, correct? So package.json specifies what are the project dependencies that you want, and this is where it's all stored. So this is my Angular application, right? So if I go one directory back, I am in this src folder now. Okay, let me do an ls. I have app here. Let me go one path back again and do an ls. And here you can see that I have other folders like bin, games, include, lib, local, sbin, share, and src. Now all these are inside my container. I hope this was enough evidence for you. I hope it was. So I'm back here, and yeah, that's how you access your container. If you want to make changes, you can make changes here. Okay, and since we are inside the container, let's just create a new file. So let's just say touch f1. So the touch command is used to create an empty file, right? So now if I do cat f1, of course there is nothing, but let me do a sudo gedit. Okay, so I don't need to give a sudo because I'm already logged in as root user. So I'm just going to do gedit f1. Okay, so it's not letting me access this command, right? Okay, guys. Anyways, that's how you access the container. Okay, so let me just clear the screen. And if you want to exit the container, exit the bash, then you should use the command exit. So when you hit exit, you're back as the Edureka user on your Ubuntu host system. Interesting, right? So I'm going to clear the screen and go back to my slides and check what's next. And then we have the docker commit command. And what this docker commit command does is that it basically creates a new image of an edited container on the local repository. In simple words, it creates a new image of any container which you have edited, correct? So let's execute this docker commit command and see how that works. Let me go to my terminal here. Let's first run the docker ps command and check this is the container ID. I accessed my docker container, so I hope some changes would have been there. So let's create a new image of that particular docker container. Okay, so I'm going to say copy and run the command docker commit and then specify the container ID of your container, and followed by that you have to specify the name of your new image. So I can say /my image, right? My Angular image. So this would basically create an image of this container which is running, and bingo, perfect, it's done. So if I run the command docker images, then there will be a new image with this name and tag. Let's verify that by going to docker images. Let's go up, and as you can see, there is /my Angular image. Perfect. This is what we wanted to verify, correct? So let me clear the screen and go back here. And yes, the webpack is compiled successfully. This was the message we got earlier. So anyways, let's not worry about that. That's what a docker command does. So if I want to stop this container service, then from the new terminal, let me just kill that container service, correct? So this is the ID. I'm going to copy this, and then I'm going to say docker container stop, and my container would have stopped. So here, yes, my service has stopped over here. Bingo. So I'm going to clear the screen in both the places. Okay, now let me get back to my slides. So the next command that we're going to talk about is the docker export command, correct? So the docker export command is basically used to export any docker image in your system into a tar file, correct? So this tar file is going to be saved in your local file system, and it's not going to be inside Docker anymore. This is another way of sharing your docker images, right? So one way was by uploading it to Docker Hub. But in case you don't want to do that, you don't want to upload it to Docker Hub because the image is very heavy. So in that case, this is an alternative which is used in the industry, where we do a Docker export from one machine and we save that image as a tar file. And this tar file is imported inside the destination system, and over there it can be accessed again and the container can be run. So let me show you an example of that by first of all getting to it. Okay, so it says Docker export, right? So this is the syntax for that. Okay, you say docker export, you use the output flag with 2 hyphens. You can specify the name of the tar file that you want to store it with, and then you have to specify your image name over here. Okay, so the image name over here is my container, so you'll have to specify your image name. So let me go to my virtual machine, and what are the docker images that I have available? There is /my Angular image, there is my custom Ubuntu. So what I'll do is, let me save this my custom Ubuntu image. Okay, this is my image and the image ID is this, right? So I'm going to copy this, go back to this terminal, and what I'll do here is I'll say docker export _, which is the flag. I'm going to say output flag is equal to, I have to specify the name of my tar file, right? So my docker tar file, I can say that my docker tar file, and here I have to specify the container name. So docker images wouldn't do for that, so I'm going to do a docker ps -a. So I have a custom image here, right? So let me save this particular image. So I'm going to copy the container ID, copy this, and paste it over here, which indicates that I will create a tar file of this particular container, and this tar file would be saved in this repository itself, Edureka @Ubuntu. Now, since it's a heavy container, it's going to take a few seconds, and it's done. And we can verify that by doing an ls. The name we gave was my docker tar file, correct? And then you can see there's a my docker tar file, which is basically a TGZ file. So if you go back to your documents, you can see that there's a new tar file, my docker tar file, that was created, and you can verify the same my docker tar file over here. This is the newly created tar file. So I can go back to my slides here, and let me just clear the screen. Okay, perfect. So going back to my slides, I've shown you how the docker export command works and what's the benefit. Now in the next slide, we have the docker import command. Now the docker import command is basically used to import any tar file. If you have any tar file which has been given to you by your fellow developer, and if you want to create a container out of that one, then you have to import it, right? So how is that possible? So this is the syntax for that. The command is docker import and then the complete path of that demo file, of that tar file. Okay, so for this particular purpose, I have already created one tar file because I wanted to create one which can be imported very soon. So I created a tar file over here, demo tar. So it is present inside my downloads folder, correct? So let me import that file. So I'm going to say docker import, and then I have to specify the complete path. So it's /home/ Edureka /downloads /demo tar. Let's hit enter, and this particular image has been successfully imported. You can verify that by seeing the first few characters of the newly created image. Okay, so let's run the command docker images over here, and you can see that just recently 23 seconds ago a new image was created, right, with the same image ID 23EF, and it is the same image ID over here, right? It starts with the same sequence characters, and right now it has no name. So that is how you easily import docker images. Okay, you first export it and then you can import it. So let me just clear the screens of both the tabs, and now getting back to my slides, I'm done with my docker import command, and now comes the advanced docker commands. Okay, so up till here we saw the docker commands which are very basic and which can be executed easily. But here comes the challenging part: docker compose and docker swarm, right? These are all advanced concepts in Docker which solves a lot of business problems, and of course the commands are also little advanced in nature. So first let's start with docker compose. There are two variations to it, and the two syntax can be seen over here: docker-compose build and docker-compose up. So these are the two commands which work very similar to docker build and docker run, right? So docker build is basically used to build a new image from a docker file, correct? Similarly, a docker compose build is used to build your docker compose by using your docker YAML file. Now your YAML file stands for yet another markup language, and now in the YAML file we can specify which all containers we want to be active. Okay, and you have to specify the path of the different docker files which will be used to create those containers or those services. And that's what docker compose does, right? It creates multiple services, and it's basically used to manage all those services and start them at one go. So it would use more than one docker file. Probably if you go through my previous video on docker compose, I have explained it in detail over there. I have used 3 different docker files, and using those 3 docker files I have created 3 services, right? And the 3 different services are the Angular service, the Express and Node service, and the MongoDB service. The MongoDB was used as a database, the Express and Node was used as my backend server, and Angular was used for my front end. Okay, now the link to this video is present in the description below. Okay, but let me just quickly wrap this up by saying that if you want to build that, you use the docker compose build, and if you want to start your docker compose and start the container service, then you can use the docker compose up. This is very similar to the docker run command. Okay, and that's what your docker compose does, right? It creates multiple docker services and containerizes each of them and gets the different containers to work together. So perfect. Let me go back to my terminal and let me do that for you. So docker ps, there is nothing. So right now we are in the home/Edureka folder, correct? So let me do ls, and there is a folder called mean stack app. So I'm going to cd into this particular folder, and here if I do an ls, you can see that there's a docker compose.yaml file. So let me do a gedit docker compose.yaml file. So over here you can see that I have specified the commands to create three different services. One is the Angular service, other is the Express service, and finally my database service. Okay, I have explained all these things in my previous video. I repeat, the link for that video would be in the description below. Okay, so let me quickly execute this YAML file. Okay, so if I do a docker compose build, then this command would look for this docker compose file inside this directory. Okay, and then it would once this image is built, I can straight away execute that command by using the docker compose up. Okay, so I'm just gonna replace build with up. This way my docker compose would also be up and running. Earlier I showed you an Angular application, and this time it's going to be a entire mean stack application, which is going to involve everything: MongoDB, Express, Angular, and Node.js. So my Express is up and running, my Angular is up and running, my MongoDB is active on port number 27017, my Express would be active on port number 3000, and Angular, as usual, would be active on port number 4200. So let's verify the same by going over here. Okay, it also says Webpack compiled successfully. So this time if I refresh this, there's a different application that would come up. Correct? So this is my mean stack application. On port number 4200 is the front end. On port number 3000, this is my server end, which simply says foobar. And then on port number 27017, there is my MongoDB. Right? So these are the three different services which are active on my various port numbers. So going back to my terminal, I can do a docker ps to verify that there are three different services of mine which are running. Now if I want to stop each of these services, I can simply do a Control-C from here, and hopefully it stops. Yes, all three services have stopped. Let me execute the same command, and this time, yeah, they're all gone, right? So the docker ps command shows no containers active. Bingo. So I'm going to clear the screen out. Okay, and go back to my slides and go to the next command. And the next advanced command that we have is the docker swarm command. Docker compose, I told you, was to basically have a multi-container application, right? And docker swarm is, however, used to manage multiple Docker engines on various hosts, right? So usually you might be aware that your Docker engine is hosted on one particular host, and you're executing your Docker commands over there, right? That's what we were doing all this time. Even Docker Compose did that. On the same host, three different services were started. But with Docker Swarm, the benefit is that we can start those services in multiple machines. So you will have a master machine, which is nothing but the Docker manager, as visible from here. And then you will have different slaves, or which are called as worker in Docker terms. So you have a manager and worker, and whatever service you start at the manager will be executed across all the machines which are there in that Docker Swarm cluster. Okay, so it says, right, it creates a network of Docker engines or hosts to execute the containers in parallel. And the biggest benefit of Docker Swarm is scaling up and ensuring high availability. Okay, so some of the commands which are associated with Docker Swarm are these. If you want to first of all start off creating a Docker Swarm, then you use this command, docker swarm init, and you say advertise. Okay, and then you have 192.168.1.100. It's supposed to be two hyphens over here. Okay, yeah, so this is how the syntax is supposed to be: docker swarm init hyphen advertise hyphen adder, and then you have to specify the IP address of your manager machine. So if I start the swarm from this particular host of mine, then this would assume the role of my manager. Okay, and in this syntax, remember, I have to specify my own IP address so that the other workers who will be joining my network would subscribe to my IP address over here. So let's quickly go and execute this first command, and let me show that to you. Okay, so let me open up the terminal, and the command is docker swarm init, which stands for initialize, with the flags advertise, adder, and then the IP address. So the IP address of my VM is 192.168.1.100. Okay, so when I hit enter, see what happens. It says swarm is initialized, and this is the current mode. This particular node is now a manager. Okay, and if you want other machines to join this particular manager as workers, then they have to use this token. So you have to just copy this, go to the other machines and execute it. Supposing this is another machine of mine. Okay, I'm giving you an example. So over here, you would have to paste that token. Okay, so this is called the token. You just hit enter and then you will join as a worker. Okay, so that's how the Docker Swarm command works. Now I cannot go into too much details with respect to how Docker Swarm works, okay, because there again it will take a lot of time. And if you want to actually learn Docker Swarm, you can go and watch the other video which I delivered a couple of months back, right? That video is called Docker Swarm for high availability. Okay, and that is a detailed video, and you will enjoy that video because with that video I've shown how Docker Swarm can be used, and you will see the power of Docker in that particular video. So I would request you to go there, and the link for it is again below in the description. Okay, so I would request you to go there if you want to learn more about Docker Swarm. But getting back to our slides, we have other commands here, right? So the Docker Swarm join is what I already explained to you. So followed by this, you will have a token. So if you give that, you can join a particular Swarm cluster as a worker. Okay, so if you want to regenerate that particular token which is needed to join that particular cluster, then at the manager's end, you can execute this command, Docker Swarm join token. So it would generate that token and give it to you. And similarly, if you want to leave the Docker Swarm cluster, then you can execute this command, Docker Swarm leave. Okay, so if you execute this command straight away at the worker's end or the nodes, then it would simply leave. Okay, but at the manager's end, it would not leave just like that. You would have to append the flag force. So let me show you that. Let me just execute the command Docker Swarm leave. If it was a worker, it would leave right away. But since it's a manager, like I said, it says use the force option. So let's use that. Okay, Docker Swarm leave with double flag force. And it says the node has left the swarm. Perfect, right? So this is all about Docker Swarm, guys. Okay, so let me go back to my slides and cover the one last command that is there for today. And that command is the Docker service command. So this command is used to control any existing Docker service, be it any container or be it a Docker Compose or Docker Swarm or anything else, right? So Docker service is a very underutilized command, I would say, because if you want to control your different nodes when you're in a Docker Swarm, then you use the Docker service. You use the Docker service command to list down the different nodes that are there in your cluster. You use the Docker service PS command to find out what containers are being executed in a particular node. And then if you want to scale the number of containers, supposing you have a cluster of 5 machines and then you have 5 containers running on each of those machines. If you want to scale those containers to 25, that means you will be executing 5 containers on each machine, right? So for that, you have to use the command Docker service scale. If you want to stop any container on any particular node, then you use the command Docker service stop. And then if you want to find out the different logs, then you use the command Docker service logs, Docker service RM, and so on, right? So the Docker service command is, let me repeat, it's used in sync with your Docker Swarm and Docker Compose primarily. So that's why these form the advanced Docker commands. So let me go to my terminal and quickly show you a glimpse of this. So it's Docker service. If we do an ls, you will not have any options listed because it says this is not a swarm manager currently. But if I start my Docker Swarm and then if I run the same command, Docker service ls, then you can see that the output is different, right? I have a few attributes here, ID, name, mode, which is basically details about the different worker nodes in my cluster. But since no worker has joined my cluster, there are no entries here. So that's how it is. So let me just end that. So that is the Docker service ls. If you want to find out the logs, then you can do that too. Docker service logs. So if you use the Docker service log, you have to specify which service you want to check the logs of and what is the task, right? So which task and which service. So it's that simple, guys. So that's how Docker service is used. Okay, guys. And again, if you want to stop any service, if you want to remove any service, you can use these commands: Docker service stop or Docker service remove. And yeah, that pretty much brings an end to my session. All right. So on that note, let me conclude today's session. And thank you guys for watching this video till the very end. If you appreciate the work that is put into this video, then I would request you to like the video, Comment if you have any doubts, comment whatever you have to say, and share that video with your friends. And foremost, please subscribe to Edureka's YouTube channel, and then you will be notified of any events in the future, right? If there's any new video that we uploaded, or if there's any live event, then you will all be notified. So please do that. And I think it's thank you from my end. Okay, so I'll see you next time. Happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!